Hi everyone. I hope I'm visible. I'm also audible to you all. Is it? देख पा रहे हो आप लोग मुझे?
Yes.
Yes, sir.
Good. All right. So basically, let me share my screen and we can start. So yesterday we have done discussion on the Palo Alto HA. So before I start anything, anyone have any questions you guys want to ask about the HA? Because we have done a lot of discussion on the HA and we understand why HA is needed, what is the key concept behind the HA, and how we can configure the HA, how we can do the link monitoring, path monitoring, how the step-by-step configuration is going to happen. So if anyone having any question, please let me know, else I will ask the questions. No questions? All right, so can someone tell me what is the difference between the link monitoring and path monitoring? Anyone? What is the key difference between the link monitoring and path monitoring in Palo Alto Firewall?
So, link monitoring means any specific link like is connected to switch to firewall or firewall to the internet. But path means if it's enter path if there is any issue. So we need to monitor the enter path. That is.
Can you give me more elaborate answer, means more practical answer? Let's suppose, because we did a lot of discussion yesterday and we agree on that. Everyone is happy with the link and monitoring and path monitoring concept. So I just want to make sure you guys are very much aware about that. What is the link monitoring and what is the path monitoring? And what is the logic behind it? So why we use the link monitoring? Manas?
Sir, link monitoring is basically for in case if we have any issue in our topology uh, before the internet. So we use link monitoring and uh, behind the internet if our services are hosted on the some other place like uh, cloud. So if any issue failure happen there, so to detect that we use path monitoring.
That's good. Fair enough. Thank you so much, Hemant. So basically, guys, we understand yesterday we are going to use the, let's suppose this is my Palo Alto 01 firewall. This is my Palo Alto 02 firewall, right? They are going to connect with two link. What is the first link going to be happen? Anyone?
HA1
HA1 control link.
HA1 is going to be control link. And what is the second link?
HA2
data link.
data.
So what all info go in the control link?
It send the heartbeat message and hello
Heartbeat.
messages.
HA configuration.
Hello. What else?
Egg.
Routing.
Policy, routing, NAT, and policy. Yeah.
No. That's the routing is going to be control and user ID info.
User IDs.
This all four is going to be there. And if you talk about the complete policy, NAT, right? ARP table, right? And complete route exchange, database, basically that's all happen to data link. So these are dedicated ports going to be used to make sure we have the controlling data link. And now these are going to be, might be connected with the switch. This is my switch, layer 2 switch. And behind the switch, we have the client which is sitting here. And this client also connected with the switch. Now we have the internet as well. Let's suppose I have the ISP here connected. So now you guys tell me, if I want to build the HA, active, sorry, let me use a different color. They should be active and this should be the passive. I have the priority 100 here and 100 here. This one having the MAC address AAAAA. This is having the MAC address BBBBB. So which one is going to become my active? Which one is going to be my passive?
The PA01 become active PH0 to become passive because lower MAC address will win. Currently, it is having same priority.
Okay, same priority. So to make the HA, we understand the priority should be lower. If priority is going to be tiebreaker, then it is going to be choose the management MAC address. And you guys should be remember because it is going to be useful. Now we discuss about the group ID, right? What is the use of the group ID in case of the active passive and in case of the active active? Anyone? What is the use of the group ID? We discussed in last section, right?
It is. It has a range of 0 to 63. I
1
think
to 63, 1 to 63, not 0
1 to
to.
63.
And we
Okay.
discuss in case of the HA active, it is going to use for the virtual MAC address calculations. But in the active passive, it is going to be normal unique identification. Both firewalls should have the same group ID. Okay, everyone agree? So make this note as well. Now we discuss in case this is my active firewall, which having the priority is 99, and this having the passive firewall, this priority is 100. So let's suppose this firewall is going to be down, okay, and this is going to become active. So how this is going to become active firewall again? What configuration special is going to needed here to become active this firewall again?
Preemption need to be
Preemptive.
enabled.
Yes. So we need to enable the preemption. If preemption is not enabled, this will never going to become the automatic active of this firewall. So preemption is going to be there. And then we discuss link monitoring. Basically, we are going to monitor the critical link. If the links are going to be down, still failover is going to happen. Path monitoring means there is the cloud issue somewhere. Let's suppose this is ISP A, this is the ISP B. If there is an issue, anything in the cloud, that is going to help you to make the communications in terms of the failover for the backup path is going to reach to the destination. If they have the different path, if this path having issue, let's suppose this is connected via this way. So it can reach via this path to destination. All right, so we all are good. Now today I'm going to explain the another scenario, that is the active means my both firewall is going to become as active means this is my PA01, this is my PO02, okay, and now the setup should be like this one. Again they are going to be using the switch 2. Again I have the client A, again I have the client, this is the client B, this is going to connect this one. Now they have the internet ISP, they are going to connect this way. So my this firewall is going to also act as active, and this is also going to act as active. But this is going to be one firewall is going to act as active primary, and this firewall is going to act as an active secondary. So all concept is going to remain same. If you want to make the active primary for this firewall, so again your priority should be lower. Means identical is 100. So let's suppose you make 90 as a priority and 100 this one as a priority. So this is going to become my active. This is going to become my means active primary, active secondary based on the priority. Now the question is going to ask, if I want to make HA of 2 firewalls, what is the prerequisite is going to be happen? Anyone? What is the prerequisite?
Same model, same software version.
Same model, same software version. So that is the both firewall have the same model. Okay. Same PAN OS version. What else, guys?
HA should be connected to HA1
No,
and
that's not
HA2.
prerequisite. That's not prerequisite. We have the prerequisite.
HA ports needs to be utilized.
No, that is going to be there. HA port is going to be
Oh.
there. We discussed 4 things in yesterday class. I hope you guys are make a note. I requested everyone to make a note. 2 things is missing. Sorry?
Hardware configuration should be same.
Yes. So hardware, that is the interface type should be the same. Okay. What else? One more important missing parameter.
License.
Yes. License should be the same. So anything, if you're going to make the HA, these all 4 parameters should be same, then it is going to be act as a HA, else it is not going to work as a HA. Now in this situation, if you want to create the HA, we have the HA1 link that is going to be there. Definitely HA1 is going to be there. HA1 again is going to be your control link. HA2 is going to be there. It's a data link. And there is a HA3 link. Additional link is going to happen in the active scenario. So what is the use of the HA3 link? That we have to understand. So what happened whenever you're going to create the HA for the active scenario? So let's suppose sometime your traffic is going via this path. Let's suppose this is going via this path, internet, because this firewall also acting as active. So there is a chance my reply might be going to come via the another path. So my reply might be going to come to this firewall, and this is going to reply back to the end user. In this case, what is going to happen? Your three-way handshake is not going to be complete. Three-way handshake not going to happen. So जो packet hai, it is not going to be processed, it is going to be dropped. So your communication is going to be lost. To avoid such scenario, what is going to happen? In case this firewall is going to receive the packet and this HA link is going to be there, HA3 link is going to be there, and it is going to receive that session information from this particular source and destination from the primary firewall. So it will redirect packet via HA3 to this user. So it is going to avoid asymmetric routing. That's why you use the HA3 link. Basically, in case of the any asymmetric routing is going to happen, this HA3 is going to be savior for you, and it is going to make sure you do not have any kind of the asymmetric routing. This is a special purpose we have for the HA3 link. So you guys have to take a note. So any asymmetric.
What is this link called? HA3?
Normal HA3 link we called. There's no special name here.
The first one is the control, second is the data, and third is
this is a special HA3 link. The HA3 link was only known as HA3 for just avoid the asymmetric routing in the active scenario. That's all.
And that is only to be used in the case of active?
Yes, only activated, no active passive.
Thank you.
Okay. All right. So we'll do this lab.
Yes, sir, one confusion.
Yes.
Sir, if through the HA2 link, if policy or net, all the things are going to sync with PA2, then why the packet is going to block by the PA2?
Okay, there is what happened. Let's suppose in active scenario, this is my PA1 firewall. Okay. This is my PA2 firewall. This is also active firewall. This is also active firewall. All right. So think about LAN point of view. Switch to how the segregation is going to happen. When you configure this PC and this PC, for this PC, you are going to set gateway of this particular firewall. So means let's suppose you have the 500 PC in your LAN. So 250 PC is going to be gateway of this firewall, and 250 PC is going to be gateway of this firewall. So half of segregation is going to happen for the LAN point of view. And it's also like it's going to be add the complication for the real production environment. But still, if you want to achieve active, you have to do it in this way. So what happened? Let's suppose this is your ISP. The WAN link is going to be new for this new IP, not same. This WAN link is going to be new IP. Okay. So let's suppose you have a subnet. You have a subnet 192.168.10.0/24, and you splitted this subnet in two parts: 192.168.10.0/25 from this LAN, and here is the 192.168.10.128/25 from this network. Means you split this major subnet into two parts. Is it clear, Manas? We have done the subnet segregation from the LAN point of view. But when I'm going to advertise this subnet to the internet, let's suppose I'm running the BGP, I might be going to advertise /24 from here as well and /24 from here as well. It might be a chance, right? But if I'm going to advertise, might be I'm going to configure the AS path, my local or higher for this particular prefix, or here is might going to be the more higher. So for remote end point of view, it is going to receive a 2 copy prefix, but might be situation it is going to land base part for this firewall. But this user is going to be always get the gateway for this Palo Alto firewall. And from there, it is going to the internet. But reply coming to this firewall because you making this path as a primary for this particular subnet. So how it is going to reach to the secondary firewall? Then you require the HA3 because this is going to be act as a session owner. So here HA3 come in a picture to just make sure path should be this way for this LAN. So it's happen in routing. That's why I'm going to cover advanced routing today, and then I will do this lab. So you guys are going to understand more better way. Make sense, Manas?
Yes, sir. Yes.
So the next step we are going to do that. Before this HA, we are going to see how the BGP is going to be configured, how the OSPF is going to be configured, how the RIP is going to be configured in Palo Alto Firewall, and how this redistribution is going to be happen. Even the default route, how it is going to be configured, and how this redistribution is going to happen. And based on that, we'll see step by step all the configurations. So let me share my screen. First, I'll do the advanced routing, and then we'll back to the HA, means the active passive, active lab as well. So let me share my screen, and let's start. Let me know if you guys are able to see my screen. Is it visual, everyone?
Yeah.
Okay. All right, so let me go here. So this is my active firewall, show system info. This is my another firewall, passive, show system info 21, and what is IP 20. So let me log in these two firewall. Okay, so what I can do that I'll connect one more router here. Let me make as a R9 router here. So this is going to be there, and this is going to be there. I'll connect with one more interface here. Let me see if there is a free interface available. So here I am going to run the BGP. Sorry. Okay, this is going to BGP, and I will configure. Hold on, guys. This is going to be my OSPF. Okay, this is going to be OSPF. So we have to build the BGP and OSPF neighborship between these two locations with the router. So let me turn on these routers as well. So already we configured the HA, but we'll see how this BGP OSPF is going to be configured and how the redistribution is going to happen. Even we'll configure the RIP, and then we'll see that. So I'll just open this R10. This is going to be R9. Okay, so this is also ready. So I will just turn on this router. Okay, let's boot up. Meanwhile, I'll go here and configure the interfaces. So guys, see, we have to configure two interfaces here. One is going to be my this Ethernet 1/7, 1/6. So let me go here 1/7 and make the layer 3. The router is going to be default. Security zone, I'll make this one as a OSPF security zone because this is OSPF neighborship. So I'll just make the OSPF just to understanding. Click OK. IP, I will assign that 30.30.1 here. And on this interface, I'll assign 20.20.1 and 2 is going to be there. So I'll go here and I'll click 30.30.1/24. And also I will assign the management profile here. This is done. Now I'll go in the 1/6. Here I'll go and layer 3. And this is going to 20. So this is going to be default. Security zone is going to be BGP. I will configure the BGP. And IP is going to be 20.20.20.1/24. And advanced, I will go here, put the management, click OK. And I'll commit as of now. I will simply commit. And I will do the point-to-point reachability test from the router point of view. It's not ready. Okay, this is router. So I'll go here and change the host name is going to be R10. Do show IP interface brief. And I'll configure the interface. The interface is going to be Ethernet 1. Ethernet 0/1. And the IP is going to be IP address 30.30.30 to 255, 255.255.0, no shit. And I will try to ping my firewall IP address, just point to point to make sure everything is up and working. So I will just check it because we enable the management profile on the firewall side, so it should be pingable and now it's pingable. So I'll just do right. That's all for as of now. I'll go in the R9 and I will do the configuration on the R9 as well. Config T, the host name is going to be R9 and do show IP interface brief. This is going to be there and I'll go in the interface. Interface is going to be gig 0/0. Gig 0/0 IP address is going to be 20.20.20.2 to 55 to 55 to 55.0. No shit. I will try to ping my peer and should be reachable. Yeah. So the lab we have done point-to-point reachability and how we make the reachable because we allow the management profile. Now what we have to do that for this section we have to configure the OSPF from this router to this firewall. Here we have to configure the BGP. So let me configure the OSPF first on the router. I'm assuming you guys have the basic OSPF knowledge, basic BGP knowledge because in Palo Alto you don't going to get the entire BGP theory classes, how it is going to configure, what is the eBGP and iBGP. If you want to learn the BGP OSPF, and that is a mandatory, and my recommendation, you must have to do the CCNP NRC where it's going to be learned in the very depth, how protocol work, what is the concept behind of this BGP OSPF. This part of the Cisco CCNP NRC course. So if you have the time, try to go through that particular module by yourself, or might be you can take any courses, but choice is yours. But my recommendation, you should know this NRC because Palo Alto Firewall also have and FortiGate Firewall also have this routing concept inbuilt in that particular box. So I'm in the router 10. Let me go in the router 10 first. And here I'll configure the OSPF. So router OSPF process ID 10. And I'll configure the network on which I want to enable the OSPF. This is my network 0. And wildcard mask is going to be there. And I'll configure the area 0. That's all. So my configuration from the R10 has done. Now I'll go back on my Palo Alto firewall and I need to enable OSPF on this particular 1/7 interface. So how I can do that? That's the more important. You should learn about it. So you have to go in the virtual router now. Under the virtual router, you have the default router under which we are doing all the configurations. So I'll click on that virtual router, and after that you have the OSPF configuration. This firewall is supporting static route, redistribution, RIP, OSPF version 3, that IPv6, BGP and multicast. So we are going to touch right now OSPF. So we have to configure the OSPF. When you're going to configure the OSPF, the very first tab you want to enable the OSPF, you should yes. Now there is one more check is available. Reject default route. What does mean? When you're going to configure reject default route, that means you cannot take any default route in this OSPF neighbor. So you are going to block all default route. That's not a good idea. Sometimes you have to take the default route to go on the internet. So you should uncheck it. Now what is the router ID? You can take anything, or might be give your management IP as a router ID. So I'll give my management IP as a router ID. BFD, that's going to be bidirectional forwarding direction. It's not required. Now you have to give the area. So we configure the area 0 on the router. So on the Palo Alto Firewall also we have to give the area 0, but in binary format. How it is going to happen? This way. Decimal format, not binary. So this is going to be 0 area 0, and area type is going to be normal, and range interfaces. If you want to configure the interface, so I'll give the interface on which I want to enable the OSPF. So my interface is basically 1/7. So I'll select 1/7 and enable. This is going to take the hello timer, date timer by default. So I'll click OK, and no other configuration. Yes.
Perfect. So I know basics of routing. So why are you configuring area ID as like this? Is this the
Because
way format
this
done in Palo Alto?
yes. So if you convert 0, basically in Cisco, if you put the 0, it's convert by default in the binary, means decimal format, like 0 equal to 0.0.0. That I was
Yeah.
understand 0 means 0.0.0.0. So it's going to work. But Palo Alto, you have to put this format only. It's going to take this format. Let's suppose you're configuring the Palo Alto area 1. So Cisco 1 is going to find, but in the Palo Alto, you have to give 0.0.0.1 like that.
Oh, okay, got it. Okay, thank you. Yeah.
So I'll click OK. Now I'm not going to do any other advanced configuration. That's all. Simply I will commit it.
And in case of area 10, it will be 0010.
Let me explain. So 10 year, there is a calculations how decimal. Let me decimal OSPF area convert. There is a calculator to binary. Okay. So you can see here. Here is example. There is let me let's stop area 1. Area OSPF area 1 into decimal. So it is going to give this like this one. Okay. If you're going to get 10, so there is a calculator I need to search out. It is going to this way, but it's not going to be always same. If you're going to give the 99 now, okay, it's the same. But if you're going to make the 199, it's still the same. But let me go like 399.
250, yeah.
So see, this has been changed now. So it's having the proper decimal number system conversion, you know that, then you can do the calculation. If else, you have to use the calculator. This is the use the total number of on bit. How many bits is going to required out of 32 bits to make 139s? So how much bits possible? If I use the 254, then it is going to be
254,
in this way.
yeah.
This is the first octet. 255.
1.254, I think.
No, it's still the first octet, right? Because it's going to be,
yeah.
But if you go make 256, then it is going to be
1.0.
1.0.
Okay.
Make sense? Okay, so
Yep.
you just have to do the, like you convert the IP number system, the same concept in CCNA, what we have done, same concept is going to use. You have to convert the binary and you have to make the on bit that is going to give the number equivalent to whatever decimal value we are looking for. Make sense? Hemant, clear?
Yeah. Thank you. Thank you.
So this is how it is going to happen, else you will have to do the calculations. Okay, so now I build this OSPF. Now probably on the router C, my OSPF neighborship has been come up. So show IP OSPF neighbor. If I just running this command, my OSPF neighborship is there. If I go in the Palo Alto Firewall, and if I check the more runtimes, here you can just focus, right corner. And here go in the OSPF, you're going to find there is one neighbor is created and the status is full. So we have successfully built the OSPF neighborship between the firewall to the router. Everyone agree with me? Give me thumbs up if everyone understand till here. If not understand, let me know. Everyone get it?
Yeah.
All right,
Yes.
good. Now I have to build the BGP configuration. So pretty straightforward. I'll go in the R9 now, and there is a command router BGP. So let's suppose I take the AS100 and here 200 is okay. Just AS number 100 and here 200. eBGP are going to learn. Make so 100 and neighbor is going to be my this one, and remote AS is going to be 200. That's all, and do right. Just one line command. Now show run section OSPF. Sorry, BGP, not OSPF. This is just one command. But if you say show IP BGP summary, my BGP is down. Now I'll go in the Palo Alto Firewall, and after going in the Palo Alto Firewall, I'll go here and I'll go in my BGP configuration. Here we have to enable the BGP again. And router ID, you can put again the firewall management IP address or any number as per LLD. AS number, what is my local AS number? That's a 200. All right. And here is again option. You want to reject the default route. Ideally should not. If you do that, it is not going to be inject any default route in the BGP table. An install route, definitely I want. So you have to click on the install route. If it is not going to click on the install route, even you are getting the route, but it is not going to install in the fifth table. So fifth table is not going to get route, then it is not going to make any kind of routing communications. So that is going to be there. These are the advanced feature, MAD, always compare MAD. So these are all part of the NRC. So I'm not going to talk this all, but yes, this feature is also available, how you can use that. Now I'll go in the advanced, nothing required. Peer group we can create. Peer group is basically to whom you want to make the peership. So I can make that eBGP peer group and my eBGP. And what is a peer? Like I can put the eBGP peer, and peer AS number is 100. From which interface I want to make the peer? That's 1/6 is there. So I'll go there and IP it will take. And what is the peer IP address? This is going to be 20.20.20.2. So a little bit you have the different configuration here in the Palo Alto side. Now click OK. No other changes required. Just you have to do the peer group to just make the BGP neighborship. We'll do the other configuration later on. But first I want to make the BGP should be up and working. So let me commit that and we'll see that after that, whether my BGP is coming up or not.
Sir, we have not given router BGP 100 command, right? On R9.
We given now.
Oh,
Router BGP
okay.
100. Okay, then never. So now you see my BGP neighborship has been come up. You can see here. Show IP BGP summary. Now we are having the BGP neighborship. And if you go on this router also, I mean the firewall, you go in the BGP, you're going to find the peers. And this is the eBGP, and this is my peer, which is up and working. That has been established here. So we are good. We are done with the OSPF configuration. We are done with the BGP configuration. But in the BGP, you can see there is no route. Even the OSPF, if you go in the neighbor priority there and status is full, but you're not having any kind of the route available, no LSA, no message pending. And BGP also you can see here, peer is there, but there is no prefix. Means if you go in the local rib, there is no prefix there. And if you go in routing table, forwarding table, you can see all route is showing that either U means up, H means host, and G means gateway, E means ECMP, and there's a preferred path. Route table you go that we have the A means active route, and basically the question mark is going to be loose route. C means connected route, H means hosted route, S means static, R means REAP, O means OSPF, OIA means OSPF inter area, OA means OSPF inter area, and that's the external route, and the BGP also it should be there. So BGP is also somewhere. B is equal to BGP route, but it's all the connected route. There is no OSPF. Only OSPF neighbor is there here, and rest are all the connected route. So let me do one thing. I will go on these routers. I will create the loopbacks. In R10, I will create the loopback as a 10. Interface loopback 10. IP address 10.10.10.10 255 255 255. And after that, I will go in the router OSPF. Then I will just go network 10.10.10.10. I'll give the wildcard mask and area 0 and do right. Now you'll see that after that, this must have one of the route 10.10 coming in the OSPF neighborship. Wait for a while. See, this prefix start coming from this OSPF, OIA route. That is the OSPF internal route. Similarly, I will go and advertise one of the 9 loopback under the BGP. So interface loopback 9. I will give the IP address 9.9.9.9 and 255, 255, 255, 255. Do right. And under the BGP, I will router BGP 100 network is going to be 9.9.9 and mask is going to be 255, 255, 255 and do right. And if you go and see on this particular router, you'll find 9 prefix is also coming here. Makes sense? But this time it's coming as a flag B, means BGP route. So we are good till here. But what is our end goal for this lab requirement? End goal is this route, whatever the route I have, loopback 10 should able to reach loopback 9 via this way. Then how it is possible? Because R9 is not going to receive the 10 prefix because it's under the BGP. If you go in the R9, you will see the route. We are not getting any loopback 10 route. And go in the R10, if you just check the route, you are not going the R9 route. So what is the solution, guys? Can someone tell me?
Redistribution.
Redistribution. So if you are the new in the routing protocol use the concept as the redistributions. So basically redistribution means you have to exchange route from the OSPF to BGP. This is the OSPF domain and this is the BGP domain. So whatever the OSPF route you have to send in the BGP, and BGP route you have to send back into the OSPF. This is known as the mutual redistributions. Okay, this you have to do that. Mutual redistributions means you have to exchange the route from BGP to OSPF and OSPF to BGP, and we have to do that. And that all is going to happen from the Palo Alto side, because the Palo Alto firewall, I created this topology purposefully to show you how to do the redistribution on the Palo Alto firewall, because it's very complex. Sometimes people are not aware how it is going to happen. So because this Palo Alto firewall is managing both protocol, so this having a responsibility to make sure you exchange the route between these two protocols. So let me do that. I'll go first in the OSPF and I will do the redistribution into the BGP. So you see here in R9, we not have the 10 subnet. Let me show you again. R9, we not have the 10 prefix route, but I will do the redistributions. It is going to be there. So I'll go in the OSPF. And in OSPF, we have the export rule. So if you want to create the export rule, you have to create the redistribution profile first. Then you have to call the redistribution profile. So I need to go redistribution profile. And I add to this is going to be add OSPF to BGP. OSPF to BGP. Redistribution. Okay. And you make sure when you do the redistribution, listen carefully, guys. 90% time engineer make the mistake here. It's too long. It's too long, not taking that much long. You have to select here redistribute. It should not be not redistribute. If you're going to put not redistribute, it's going to get problem for you. So you have to select redistribute. So click redistribute. Priority you can give just one, any number, and you have to select which protocol you want to redistribute. OSPF I want to redistribute. That's all. No other configuration needed, and click OK. OK. Now done. Now, once we configure this profile has been configured. Just go in the OSPF, go in the export rule, and here you just have to make the BGP to OSPF. And by default, if you're going to redistribute, it is going to become the E1, E2 route, which having the metric 20. So I will select the E2, not E1, and I'll click OK, and I will commit. That's all. So wait for a while. So I have done OSPF route redistribution into BGP. Okay, let me see what happened. Give me 1 second, guys. Okay, let me add the interface. I just forgot to add the interface. That is the 1/7. Okay. All right. Let me try. So it's thrown an error. Virtual or default distribution profile was a BGP source type OSPF. Hold on, guys. Okay, leave it this one. I know where is the issue. So basically, I created this redistribution profile where I'm saying OSPF to BGP. So I need to go in the, let me remove this one. I need to go in the BGP and I have to go in the export here and sorry, the distribution rule, allow default rule. Also, I need to click and name is going to be OSPF to BGP. I'll explain. Hold on. I know what is the issue. Wait for a while. Yeah. So I'll explain what was the mistake I was doing. Let me show you once the route is going to be advertised. So this is done, right? And you guys see now if I go on the this one, show IP route R9, you start getting this route 10.10. Earlier it was not there. So what was the mistake I was doing, guys? Basically, I'm going to say I need to advertise my OSPF to the BGP. So source was OSPF and I was redistributing OSPF into OSPF. That was the wrong. I need to redistribute this OSPF into the BGP. So I need to go in the BGP and here I need to redistribute. And when I redistribute, I also going to say that you just have to allow the default route. If is there any default route is available. So right now we don't have any default route, but if there is a default route is going to be there, it is going to be advertised. So one way redistribution has been happen. All right. But if you go in the R10, still you are not getting the 9 prefix. The 9 prefix which is coming here, show IP interface brief, this prefix is not coming. So if I want to advertise, again I have to create the redistribution profile. I'll go here, but this time I'm going to BGP to OSPF. And this is going to redistribute, again give the 1, and source is going to be your BGP, not OSPF. And you have to put in the OSPF. I'll click it this. Now I'll go.
What is the user priority one? How it helps?
That's just significant to give the priority. Any route you are going to give the priority. Let's suppose 2 redistribution are happening. So priority is just going to be give the means what is a route priority means whenever going to configure any route BGP OSPF you have to give the priority just a value, but it's not going to make any significant unless you have the 2 route with the same prefix. So higher priority is going to win, lower is going to be not win. Let me show you, it is written here somewhere. Give me 1 second. You are going to find here.
Second
Priority.
option after name.
Yeah. So
Different profiles exist. Then in that case, the priority.
see, there is a 2 priority. Lower is going to match first. If the same prefix is coming 2 priority, right? So lower is going to be redistribute or might be get the preference. That's the meaning of the only priority. Okay, clear?
Okay, sure.
So in case of 2 identical copy of the route we have, one is coming with the priority 2, one is coming with the 1. So who is going to select it? Let's suppose one is coming with the EIGRP, one is coming with the BGP. So EIGRP having the AD value 90 and BGP having, let's say BGP having a 20. But if the by default BGP is going to be selected, but EIGRP priority is going to be 1 and BGP is being 2. So still my BGP is not going to be selected. EIGRP is going to be selected. This is the meaning of the priority. Okay. Raman, clear?
Yes, Pankaj. Thank you.
Okay, good. So this is going to be there and I'll just select OK. And now I'll go on the OSPF this time. And here I will go in the export rule. And after going that, I will BGP to OSPF. And this time it will not run an error because source I change it and I'll commit it. So now you see it's done. And if you go on the router R10, you are getting the 9 route. So we have the complete route exchange between here to here. So now if I try to ping from loopback 9 to loopback 10, is it going to ping or not? What do you guys think? We have the 9 till here, 10 till here.
It should be pinging.
It's pinging.
Something in policy.
Policy need to create, I think.
Yes, that's the correct answer. So I asked this purposefully. We have a routing, okay? If I'm here and I'm learning this route 9.9. So we have the forward and reverse route from the both sides. There's no problem. It's still not going to ping. Why? Because there is zone are difference. When this is my OSPF zone, this interface in OSPF. Sorry guys, give me 1 second. My pen is not working for some reason. Okay, so this is going to be my OSPF and this is my BGP zone. So they are the inter zone, and by default, what is going to be happen? Inter zone, anything is going to be blocked. Routing is there, but after routing, you require the policy. If there is no policy, it is not going to allow. So I require the bi-directional policy. Means if I am going to ping 10 to 9, it is going to require the policy, and 9 to 10, it is going to require the policy. So let me create the bi-directional policy, and then it is going to ping only. So I'll go here and create the policy. OSPF to BGP and BGP to OSPF. I don't know this will take that much long or not. Okay, I'll add this same policy. So I'll create the bidirectional BGP and OSPF source zone and destination. I can include a subnet as well, but I'm not including. I'm just creating this policy to allow any from the BGP to OSPF. Just make sure we have the ping. So unless and until we have the policy, both direction, BGP to OSPF, OSPF to BGP, we cannot ping to each other. So I will go here and then I will check the ping reachability. Now you will check again and now it should be reachable. See, I'm able to ping. If I go here as well and try to ping 10.10.10 with source 9.9.9, it is reachable. We are good. Now, if this PC want to go on the internet, how it is possible? Anyone can think, let's suppose this want to go on real internet. I want to go on the internet from here to here and from here to here. How it is possible?
Netting to be performed.
Step by step. I want to learn step by step. What is the first step?
Default route needs to be
Routing netting policy.
So route is, focus on the routing first. Default route. Because to go on the internet, we have the 10 lakh route on the internet. So we are using the default route here to go on the internet. Static. We all agree?
Yep.
So this route need to inject it on the BGP and OSPF both. Make sense? So let's understand how we can inject the default route BGP into OSPF. Then we'll go for the next step. Right now, if there is no default route, if I try to ping from here 8.8, this is the real internet. It's not going to work for me. If I just try to ping here also 8.8, it is not going to ping me because we do not have the default route in the routing table. So we have to inject the default route. Firewall have a default route, but that default route must be come in the BGP and OSPF. These doesn't have these routes. But if you go and check the firewall have the default route. If I go here, virtual route, see, there is a default route available. So I need to redistribute this default route into the BGP and OSPF. So let's do a step by step. Again, I have to create the redistribution profile. Okay. And this is my static route already available. So I will create this default route, default static. And this is going to be, it is not going to take that much long. Redistribute, I'll give the priority 1. Now, what option I need to select here? Anyone? BGP connected, OSPF RIP. What is going to be there?
Connected. Or static.
Static should be there, not connected. Okay. So I need to select the static route. And if I want to match the interface, I'm not going to match. Let me do without matching. Should be there. But if it's not going to work, I will show you. Now I just created one of the default route and I'm just saying any static route default available and I have the static route. That's the redistribution profile is there. Now I'll go in the OSPF first. And here is export rule already BGP. I will add one more thing, that is the default route. Click OK, OK and commit. So I'm sending default route into the OSPF first. And let me see if it is going or not. Okay, so let me go here and check again. This is my R10. So I'll check it here. And there is still no default route is coming. So let me see. Let's wait for a while. Okay. So let me go here. Let me go in the OSPF. And very first thing is when you configure the OSPF, export rule, see this is missing. Allow redistribution default route. If it is not going to be checked, Even you have done the all right configuration, default route is not going to be injected. So this is the first mistake I have done. So I have to make sure allow redistribution default route. It must be checked. Let me commit after check, then I will see that. After that, it should be there. If not there, we just have to add the interface, nothing more than that. But I believe it should be there. Interface not needed, it's optional. And see here, we have the default route. Make sense? So now if I try to ping, will it going to ping my internet or not? What do you guys think?
No, sir.
No. What all are missing still?
Policy.
Policy.
And NAT. Two things are missing because you go on the internet, you have to NAT our subnet. So let me do the BGP as well. Then BGP also I will do that. BGP still not have default route. So I will first inject in the BGP. Then I will do the NAT and policy. So let me go and do the BGP also. So I'll go in the BGP. And see, this must be selected. Install route and redistributions. Allow here already selected. So it is not going to create a problem this time. I'll go here. Static. Okay. And commit. So let's see. And now if I go here again, say this BGP also have default route, but if you try to ping 8.8.8, it is not going to ping. So we have to do the NATing. How NAT policy? First, we need to create the policy. So let me create the policy. I will create the policy. Let's suppose BGP, sorry, OSPF, BGP to internet. Okay. And in this, I will just match the any route coming from the BGP, any route coming from the OSPF from any source. Okay. If they want to go on the untrust internet, any application, anything should be allowed and commit OK. Now I'll go in the NAT. NAT is very important. NAT, I will configure OSPF, BGP, SNAT. I will select that BGP, OSPF. This is going to be untrust, one by one, any source, any destination. I will just do NAT, basically PAT on my exit interface. I'm assuming you guys are very much champion on this because we already covered it. And then I will check whether they are able to reach on internet or not. So this is the third type of redistributions when I'm going on the internet. So static. So if I go now again, and if I try to ping, see, you are able to reach on the internet. Real internet. It's not fake internet. It's a real internet. Even if you go from there also, if I try to ping, see, you reachable. And you try to trace 1.1.1, it's going on the real internet. So you are going on the real internet because we are doing the NAT routing policy redistributions. So let me summarize what I have done. We configure the OSPF. We configure the BGP, mutual redistributions. We redistribute a default route into BGP and the OSPF. Now the next stage, and these are going on real internet. This is a public IP address. Let's suppose any question till here, guys, before I move the next redistribution process. Anyone having any question or everyone is good? Give me thumbs up if all are happy. If any doubt, raise your hand. All good? Okay, that's fine. Now there is a requirement. Let's suppose this user want to talk to this DMG PC. So first of all, this DMG PC firewall should be disabled. Only you can ping. Else, if everything is fine, still you're not going to ping because firewall is going to block your ICMP packet. So I'll make it off. I'll make it this off. I'll make it this off. So it is not going to block any packet. So now you have a requirement from this PC. Hold on, guys. From this router to reach this PC. How can we do that? Anyone can think about it? How it's possible we can do that?
Sorry, what's the question, Pankaj?
So let's suppose now I have a requirement to make a reachability from this to this subnet. Means 192 to this 20, 30, or might be whatever the loopback is there. It's a 9 loopback, it's 10 loopback. You have to make the reachability. Is it possible we can do that?
Yeah, so routing and redistribution
NAT policy.
policy.
So
Ethernet, I think we require.
no, NAT basically it's like simple LAN to LAN. Let's suppose these are the LAN network. You don't go into the internet. So NAT is not required anyhow. I'm not going to use the NAT. Do you guys
Just
think
routing.
routing is going to require? What routing is going to require?
Static routes, I think, do we
This is the
require?
connected subnet. This is a connected subnet here available. Connected. It's a connected subnet. So connected also we can redistribute, na? BGP and OSPF.
Yeah, correct.
Right?
For connected routes, we can redistribute in BGP and OSPF.
And BGP OSPF route already coming in the firewall, and this is connected. So only we have to redistribute. See, we have to bring this subnet 192 till this 10 and 9. Right now, this subnet is not coming. You can see here, if you go and check routing table, there is no 192.168.10 subnet is there. So you cannot reach. So you have to send this subnet, but firewall have this subnet. And how it is available in the firewall? If you go in the network, in the firewall section, this is going to be available as a connected route. Let me show you. This is the 192.168.10 route. This is a connected route, AC. So you just have to advertise in the connected to the BGP and OSPF. So we have to create the redistribution profile here and select redistribution 1. And this time is the connected. Clear? And then click OK and go in the OSPF, export rule, make the connected OK, go in the BGP, redistribution, make the connected, sorry, OK, and config. Okay, so now if you go here and check, you are start getting the 192 subnet. Not only 192, it's all connected route. So if I want to filter, I have to apply the filter. Even 172 also start getting here. So even also go here because all connected route start redistributing. So if you want to filter that, only one specific prefix, so you have to create some filter list also. So let me just ping now. It is going to ping or not? What do you guys think? Ping is going to work or not?
No, sir, we need policy.
Yes, we need a policy because there is no policy from BGP to DMG zone. So I will create here policy BGP OSPF to DMG. So I will just add, let me here, BGP OSPF. Destination, I will add DMG also here. So I'm just adding in the existing policy. So any packet is going to come. And for reverse also, if this PC want to talk from DMG to BGP OSPF, so let me add this one also. So I'll go here. No, I need to create a separate policy. Or might be I'll add the DMGs in source as well. If you're coming the packet from the DMJ, it want to go in the destination, it is also going to be allowed. So both way I just make the connectivity. But here you can see now if I'm going to ping, it should be pingable. See, it's reachable. Anywhere I go from here as well, 10.10, it's reachable. From DMD PC, it is not going to work. Why? If I just try to ping 9.9.9, it should be pingable now because the commit has been done. And even I go ping for 10.10, it is going to pingable. The commit was done now. So we have the end-to-end reachability with the connected subnet also. So we
Why you
address,
said earlier no? Any
sorry,
specific reason?
what?
From the DMZ PC, while you are pinging, you said no, it will not ping. So,
Because commit was, I was thinking commit is in progress, it is not
okay,
going to
okay.
ping. So, but it's
Okay.
happened very fast. That's why it's able to pingable. I was thinking commit is in progress, it is not going to ping. That was the reason. But commit was
Got it.
happen, so it is like start pinging. Okay, so we done with this connected static BGP OSPF. Now, let's suppose you want to configure the RIP. Then how it is going to happen? Let's suppose you want to configure the RIP on this router. Let's suppose instead of the OSPF, you want to configure the RIP. So let me do that. I'll go in the R10 and I will remove the no router OSPF 10. So you can see do show run section OSPF. There is no OSPF configuration now. So now I'll configure the router RIP, right? And I'll configure the version 2 and I'll give the network that is going to be 10.10.10. Another is going to be 30 here, 30, 30, 30, 30, 255, 255, 255.0. Sorry, it's going to be not take wildcard mask. Okay, leave it. It's going to be glassful. Section RIP. This is the RIP configuration, RIP version 2. So now if you see show IP route, there is no route because RIP must be configured on the Palo Alto side as well. So to enable the RIP, you just have to go in the router and you have to go in the RIP and I can, okay, leave it this configuration. I'll go here and enable the RIP. This is going to be deselect and I will configure the interface where I want to enable the RIP. The interface is my 1/7. So I'll select the 1/7. Nothing is needed. Now I will, if I want to redo the redistributions as well, so I'll call all the redistribution means BGP to, now we have to configure BGP to RIP. So let me first do this neighborship, allow default route. Let me click it. First, let me commit it. I will verify whether we have the end-to-end reachability or not in terms of the RIP. So my this routes 30 and 10 should start getting on the RIP table of the my this. If I go here, interface, it's enable peer, and if you go to the routing table, you getting this route as a R. R is indicating this route is coming from the RIP. You're getting the 30 route also as a RIP. That is the R. So you have the RIP reachability. And if you go here and check show IP route again here, you're not getting any remote route from the RIP because you're not doing any redistributions. So I have to redistribute my BGP into RIP and default into RIP, connected into RIP. So how it is going to happen? First, I'll create one of the redistribution profile, and this redistribution profile is going to be like BGP to RIP and RIP to BGP. So let me make this as a RIP to BGP. BGP, this is the one. So source is RIP and you want to advertise in the BGP. That is the one thing. And one I'll create BGP to RIP. So source is my BGP and I want to send in the RIP. So this two profile are created. Now I'll go in the RIP and export rule. I'll go here and BGP to RIP. Source is BGP. I want to send the RIP. And another is default route. Another is connected route. I'll do this. First, let me do the commit and then do the reverse way. So now you see here, probably you're going to get more routes. See, this is default route start coming from the RIP. This connected route start coming from the RIP. And even 20 start coming from RIP. So all are coming from the RIP. Every route you start getting from RIP. Make sense? And now if you go from the reverse way, you go here and go in the BGP, redistribute. I have to go and enable RIP to BGP. So this is going to advertise the RIP to the BGP route. So we cover all the routing protocol. Any doubt, guys? Anyone have? Are we good till here? Did you guys understand this entire key concept? Still reachable? And if you just check it, routing is still there. But these are all the BGP route, and still you are getting all the routes without any problem. Clear to all?
Yes, sir. Sir, can you show like one filter also?
Okay, filter, you want to do that?
Yes, any one filter.
Okay, so let's suppose connected, you advertising all the connected route. 1, 2, 3. You want to send only one route. So when you go and redistribute like connected. So where is the profile? So in connected, we have to just select the interface. Not by default, all is selected. Now I want to advertise only the 1 by 2. Okay. So I'll select the interface 1 by 2 only. So this is going to be only redistribute. So right now you see here we are getting all subnet. Means 172 is also coming, 192.1 is also coming, 192.10 is also coming. But now I want to just send the only one subnet. So I'll go here and it's apply for the one interface. I'll commit. Then rest is going to removed. If going to allow all, it is going to be allow all the prefixes. Okay, so now you see here, only you're getting the subnet. Make sense? Rest are removed. If you go here also, you just check it, show IP route, you remove 172.16, 192.168, 1.0 as well. Any other question, guys? Anyone have? Are we good? Tomorrow I will cover active then. So already we covered theory part, but I will do the active because in this lab I really wanted to cover this routing part. So you guys are going to be happy with the routing as well. If no further question, let's conclude it here and see you tomorrow, guys. Bye bye. Take care. Have a great evening. Good night to all.